Hello, this is Daily Putnam Challenge Day 7. Here we go. 1. And I also meant daily push up. 2. And Putnam. 3, 4, 5. So our Putnam problem today comes from Putnam 1991. It reads, let A and B be different n by n matrices with real entries. If A cube equals B cube and A squared B equals B squared A, can A squared plus B squared be invertible? Okay, so we are asked if we can invert the specific matrix A squared plus B squared, and then we are given that A cube minus B cube equals 0, which is of course A cube equals B cube, and then we also know that A squared B equals B squared A, which implies that A squared B minus B squared A is equal to 0. 6, 7, 8, 9, 10. Okay, so what do we do here? I'm thinking we can add these two equations and then attempt to, extract A squared plus B squared from it, and then see if we can have find any property that is true to that expression. So we can have A cube minus B cube plus A squared B minus B squared A equals 0. 11, 12, 13, 14, 15. Okay, so if you factor this out, this gives you something like A squared minus B squared. Let me see. Because we want to factor out A squared plus B squared, but then we're getting A squared minus B squared. Where were we? 16, 17, 18, 19, 20. Okay. You know what? Let's do it this way. Let's erase this, and then note that since this term is equal to 0 anyway, that means it's equal to its negative, So 0 is the only one that has that property. So in other words, we can also write this as A squared B plus B squared A. Okay, that way I can extract A squared plus B squared when I factor. So this is A cube minus B cube minus A squared B plus B squared equals 0. So this gives you A times A squared plus B squared. Okay, so we've combined this term and this term, and then finally the remaining two terms will be minus B A squared plus B squared equals 0. Of course, you can factor that out further as A minus B A squared plus B squared equals 0. 21, 22, 23, 24, 25. So what now? Look. So since A and B are distinct, okay, they are different matrices, that means this particular term, this particular matrix, the first factor is not equal to 0, correct? That means for this equation to be true, the second factor has to be equal to 0. And since A squared plus B squared is equal to a 0 matrix, that means it's not invertible, because recall, when you invert a matrix, it's proportional to 1 over the determinant, and if you have a 0 matrix, its determinant is 0, therefore it is non-invertible. Therefore, we conclude from the fact that A squared plus B squared equals 0 that A squared plus B squared is not invertible. Okay? 21, 22, 23, 24, 25. Did we stop at 20 before? I forget now. But anyway, yeah, it's a straightforward problem once you realize, once you write in the same way the b squared a minus a squared b, and then factor out the relevant term a squared plus b squared. But anyway, thanks for watching, guys. This is day 7 of push up while solving a Putnam problem. Bye bye. See you next time.